Put your fingers gently right on the front of your throat. Yep, right now. Just let them rest there. And say, ah, out loud. Go ahead. Ah. Do you feel that? There's this tiny, buzzing, trembling feeling right under your fingers. But what exactly is going on in there?
So, what is vibrating, and how in the world is it making that sound? Think about it for a second. Your voice seems completely invisible, right? But you can literally feel it moving. We're going to solve this mystery today and uncover the secret behind every single sound you hear.
Okay, so to figure this out, let's start at the very beginning. Where do sounds actually begin? Think about how many different ways we can make a sound. When you hear clapping, the sound starts with your hands smacking together. Hearing a ringing sound, that starts at a bell. A drum beat comes from the drum skin, your voice, as we just felt, comes from your throat, and music bumps from a speaker. These sounds are totally different from one another, right? But what's the one thing happening every single time? Well, every sound we hear, from a buzzing bee to a giant bass drum, starts its journey at a very specific place. And that brings us to our very first major keyword, sound source. A sound source is literally just the object or the specific part of an object that produces a sound. Sounds don't just magically poof into thin air, right? They have to be produced by a source. So if a dog barks, the dog is the sound source. When you were saying ah a second ago, the source was actually your invisible vocal cords hidden right inside your throat.
So, we have our source, but what are these sources actually doing to make noise? What exactly is a vibration?
Well, a vibration is a rapid, repeated back and forth movement. Think of it like this. Imagine a plastic ruler hanging over the edge of your desk. If you push the free end down and just let it go, it doesn't just sit there. It wobbles up, then down, then up again, super fast, over and over. It's moving back and forth. That repeated back and forth movement, that's a vibration.
So here is the unbreakable three-step scientific chain. Step 1, we have our sound source. Step 2, that source begins to make a rapid back and forth vibration. And finally, step 3, those vibrations actually produce the sound. First the source, then the vibration, then the sound. It happens every single time.
Hold up though, let's pause here because we need to bust a really common myth. A lot of people think that if an object vibrates really fast, it makes a really loud sound. Nope, that is a total myth. The speed of a vibration definitely changes other things about the sound, but speed absolutely does not equal loudness. As sound detectives, we've got to keep volume and speed completely separate.
All right, detective hats on. Because science isn't just about listening. We can actually use our eyes and our hands to find evidence of these vibrations too. If you pluck a guitar string, it moves back and forth so incredibly fast, it literally looks like a blur. You can actually see it vibrating. With your voice, as we figured out earlier, you can safely feel the buzzing right there on your throat. And if you tap a drum, you might actually see tiny light objects jump right off the skin. You can literally observe the movement with your own eyes.
Which brings us to another huge myth. What if you can't see the vibration? Sometimes people think, hey, if I can't see it, it just isn't vibrating. Completely false. The fact is, a ton of vibrations happen hundreds, maybe even thousands of times every single second. They are just way too fast or way too tiny for our human eyes to catch. Like, just because a speaker cone looks completely still from across the room while it's bumping music doesn't mean it's actually still. The movement is just hiding from your eyes. And if you don't believe me, here is the absolute ultimate proof. Stop the vibration and you stop the sound, period. If you pluck a guitar string and let it ring, you hear the note. But the exact second you gently touch that string with your finger and stop it from moving back and forth, silence. The sound instantly fades away. The sound literally only exists because of that back and forth vibration.
Okay, let's put this to the test with an awesome experiment. Get ready for the jumping rice experiment.
Now, to do this right, we have to think like real scientists. And scientists use a specific cycle to solve mysteries: prediction, observation, and conclusion. First, we predict what's going to happen before we even test anything. Then, we closely observe what actually happens during the test. And finally, we make a conclusion based on our evidence to see if our prediction was actually right.
So here's our setup. We've got a glass jar. Stretched really tightly over the top of it is a piece of plastic wrap, held super securely by a rubber band. It's perfectly smooth, kind of like a tiny drum. On top of that plastic, we place just a few grains of dry, uncooked rice. Now, What do you predict will happen to that resting rice if we make a really loud sound near the jar without ever actually touching it? Take a second and form an educated guess.
Got your prediction? Are you ready? If we clap loudly or put a loudspeaker right next to the jar, the rice jumps. It literally dances around on the plastic. Now, a big myth here is that the wind from a shout just pushed the rice around. But if we do this super carefully without blowing any air at all, the true fact is this. Sound vibrations from our source travel through the air, hit the plastic wrap, and make that stretched plastic vibrate back and forth. The plastic is what makes the rice jump. We're just using the rice as a clever little tool to see those invisible vibrations.
And to make absolutely sure our experiment is reliable, we have to run what's called a fair test. That means we only change one thing at a time. That's our independent variable. In this case, we're just changing the strength of the sound. The dependent variable is what we're excitedly observing happening, so the rice jumping. And our control variables are the things we keep exactly the same. The same jar, the same plastic wrap, and the same rice. Because, if you just blew wind from your mouth on the rice, that would totally ruin the fair test.
All right, you've got this down. Let's do a quick final sound challenge to test your detective skills.
Let's do this rapid fire. When you hear a ringing bell, what exactly is vibrating? Yep, the bell body. What about a beating drum? You got it, the drum skin. Music from a speaker, the speaker cone. A person talking, your vocal cords. Fantastic job. In every single one of these examples, a specific part is rapidly moving back and forth to create the noise.
Which brings us to the absolute foundational rule for everything we've discovered today. Say it with me. Sound is made when something vibrates. You've got to remember that. A sound source vibrates, moving rapidly back and forth, and that movement is exactly what produces every beep, boop, crash, and whisper you'll ever hear in your entire life. But wait, this actually leaves us with one massive mystery left to solve. You now know the secret behind how sounds are made, but if a guitar is vibrating all the way on the other side of the room, how does that invisible vibration travel all the way across the room, through the air, and actually get inside your ears? Like, what exactly is happening in the empty space between you and the sound source? Think about that one, and I'll see you next time to solve it.